Hi, hello, welcome to the Dr. Code. Let's dive into the storyboard. Leetcode 39 combination of some. The given inputs are candidates and target. We can use unlimited candidates that should form a group that summation should be equal to a target. If you do not understand this, that's completely fine. We are skipping this and go back to visualization. First, we have to understand the basics of a decision tree. First, we can use skip. Now we can use skip. Now we can use skip. At the end, we get some of the combination like use, skip, skip, use, skip, skip. That's it, the decision tree. So just going back to the main story of the problem. First, we have to sort the given input array. But wait a second, why we are sorting the given input? Why can't we do that without sorting? Of course, yes, we can do without sorting, but we can just cut out some branches in a decision tree so we can see during the computation. After sorted the given input array, we got 2, 3, 7 and star represent the index at 0th position, 0 current summation. In the decision tree, first we have to use adding 2 plus 0, we got a 2 and add 2 to the array. And it goes to the left branch. Again add 2 to the 2, we got a 4 and 2, which goes to a left branch. And again we are adding 2 plus 4, we got a 6 and adding 2. It goes to a left branch. Again we are adding 2 plus 6, we got a 8. Just again. Actually 8 is more than target, so why we need to go further? We know for sure the data are in ascending order. If you go further, anyway, it's going to increase the data for sure. So we just cut the branch here. We don't need to go further in this branch. So in the right branch, we have to skip it. The index moving to the next position. And it just go to the right. We are adding 3 plus 4. We got a 7. And adding to the subarray. And it goes to the left. Hey bingo, we got a 7. That's the target. So we are adding the subarray to the result. So we don't need to go further, we just cut the branch here and go back to the parent, and now we are going to the right branch, so we have to skip it, move the index to the next position and it goes to the right. Now we have to add 7 plus 4, it's 11. We know it already, it's just greater than the target, so we have to cut the branch here. Again, we have to skip it, go to the right, moving the index to the next pointer, and it's going to the right. In the left side, we having the space problem, so we move it to the left little further. Adding 3 plus 2, we got a 5 and add the 3 to the array and it goes to the left. Now we are adding 3 plus 5, we got a 8. We knew it already, so it's already greater than our target, so we are cutting the branch here. Again, we are going back to the parent. In this time, we have to go to the right, so we have to skip it. We are moving the index. Again, it goes to the right. Now we are adding 7 plus 2. It's just greater than the target, so we are pruning the branch here and it's going back to the parent. Skip it and moving index to the next, and it goes to the right. Increase the branch little further because of the space issue. 3 plus 0, we got a 3 and add it to the end and it goes to the left. Again adding 3 plus 3, we got a 6 and add the 3 to the end. It goes to the left. Again we are adding 3 plus 6, we got a 9. Already greater than the target, so we are pruning the branch here and going back to the parent. We have to skip the index and moving to the next, and it goes to the right branch. 7 plus 3 is just greater than the target, so prune the branch here and going back to the parent. Here we are just skipping the index and move it to the next. And it goes to the right branch. 7 plus 0, we got a 7 and added to the subarray. And it moves to the left branch. It's a 7, bingo, we got a target. Add the subarray to the result. Going back to the parent now to skip the index and moving to the next. Just wait a second. We are just coming out of the index, so we just break it here and going back to the parent. We found two combinations, written it as a array form. First, we are initializing the result, starting the candidates dot sort. We are defining the decision tree def dfs I comma sum slash comma sub. First, we have to include the base case if current sum greater than or equal to the target, or if I greater than or equal to the length of the candidates, we have to break the branch. And again, if current sum is equal to target, adding the subarray to the result but in a deep copy, and then we have to just return it. In the left branch, dfs I comma cursum plus adding the current index value plus add the value into the subarray. In the right branch, we have to skip it. DFS moving the index to the next position and current sum as it is and subarray as it is. At the end, we are calling the function dfs 0, 0, open close. Finally, we are returning the result.